We begin with a quiz problem where we have 5 kilograms moving at 10 meters per second and another 5 kilogram mass moving in the opposite direction at some unknown velocity v. This is before they collide. They collide head-on, and after collision the two masses stick together into a combined 10 kilogram mass, which is observed to be moving at -2 meters per second. Now we've implicitly taken this as the positive direction. Left to right is the positive direction, so that this velocity is positive and this velocity is negative. The task is to find the unknown velocity v. We collect our information and we see that we have a mass m1 and a mass m2. Both masses are 5 kilograms. Velocity 1 and velocity 2 before collision. Velocity 1 before is 10 meters per second. Velocity 2 before we designate by the symbol v. We can then say that the total momentum before collision is 5 kilograms times 10 meters per second plus 5 kilograms times v. That is the momentum of the first time plus the momentum of the second. And after collision we have a 10 kilogram mass moving at -2 meters per second, so its total momentum is -20 kilogram meters per second. We can stop at this point and see that we have a 50 kilogram meter per second momentum plus an unknown momentum before collision and a -20 kilogram meter per second momentum after collision. We know that the momentum before equals the momentum after by the impulse momentum theorem, or by the conservation of linear momentum. How are we going to add a 50 kilogram meter per second momentum, or what are we going to do with a 50 kilogram meters per second momentum to get a -20? That tells us that this momentum has to be the difference, -70 kilogram meters per second. A 5 kilogram mass with a momentum of -70 kilogram meters per second had better be moving at -14 meters per second. Now we'll see this a little more formally. We can create an equation by setting the total momentum before to the total momentum after collision, and we see that we have 50 kilogram meters per second plus 5 kilograms times v before collision, -20 kilogram meters per second after collision. We can easily solve this for v. We add the -50 kilogram meters per second to both sides, and we end up with 5 kilograms times v is -70 kilogram meters per second. V is -14 meters per second, as we saw earlier. Looking at this even more formally, we could have written the conservation of momentum in this case as the momentum of the first object, m1 times v1 before, plus the momentum before collision of the second object, m2 v2 before. And that's going to equal the total mass, since the objects stick together, multiplied by whatever velocity we have after collision. We know everything. We know the mass of the first and the second, here, 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 and here. We know the velocity of the first. We know the velocity after. That is everything except v2 before. So we can easily solve this equation for v2 before, adding the -m1 v1 to both sides. That's going to give us a -m1 v1b here. And then dividing by the m2. And we're going to obtain this expression, which tells us that we take the difference between the velocity after, or the velocity after minus the velocity of the first before, and then divide it by the mass of the second object.